Sine squared plus cosine squared equals? Try that again. Sine squared plus cosine squared equals 1. That's funny. Some of you are like, oh yeah, 1. Did anybody tell anyone about their sort of newfound love? Did you get any responses? All right, tell somebody and see how they respond. And hopefully you can tell them how they should respond. Now, we're going to make my first identity book. Yeah, my first identity book. And you'll be able to like put it on your nightstand and you can read it before you go to bed. It can be the first thing that you read in the morning. Now, in all seriousness, it's a handy reference. It's a handy resource that you'll actually look at quite a bit in this chapter. Okay, but you can also read it, like I said, before you go to bed and when you wake up. But what I really mean by that is students will hold on to this. I see them get it back out next year if you continue to take math. And I'm not just saying that, like people do that. So actually going to give you a little class time to do this. And if you're like, I have no idea how to do it, relax, I'm going to show you. But the identities that we wrote down yesterday in your notes will ultimately, you'll be copying them into your book. So after we do a little folding, make sure that you access your notes because that's what I actually want you to do. I want you to do just a little bit of copying. Okay, you got to fold this thing a couple different ways. How about like this? Fold it this way. I don't think of that as a hot dog. No, that's not a hot dog. That's a Joe sub from Roma's right there. Fold it like a Joe sub. Has anybody ever had a Joe sub? Usually I have like at least like a Roma's either employee or customer, loyal customer. So you know about a Joe's? Okay. It's like my favorite sub. There's just everything's on there. Sorry. Okay, and then you fold it the other way. The other way. I don't know what that makes you think of. Does it make you think of, I don't know, alligator maybe? Chicken patty? All right, your love language is not food. But fold it the other way twice, basically, to get it into this size. Yeah, you fold it again the same way. So fold it the other direction, again, like a hamburger, but then fold it again that same direction.
Hamburger twice?
Hamburger twice, sounds good. If you're leery about folding it, yeah, that's right. Now, this looks like a book from the outside, but if you open it up, it's not very book-like, okay? But it's all folded. What we have to do, though, is unfold it and make a few more moves, okay? So unfold it. Like you want to completely open it up. You're actually going to fold it back, but you're folding it back a direction that we have not actually done yet. That is now fold it this way. Again, I guess that's like a hamburger, but we need it to be in this size. Okay, it looks good. Open that back up and fold it so that you're ready to do this. Now, on the top right now, I have the crease. On the bottom, it's like open. Are you with me? On the top is the crease. On the bottom, it's open. This line right here, or maybe I should say this crease right here, needs to be cut or torn. So from the top, you're going to cut or tear halfway down. Sometimes people break out scissors if they actually have them. Otherwise, do you know how to make a nice tear? Okay, I put a pretty hard crease on just that purple line.
Is it on both sides of the paper or just the one side?
Well, it's folded, so it's on both sides. Good question. So I'm going to tear halfway down. If you watched how I tore that, I really just kind of
like this?
Yep. Some tears are better than others, but it looks like you guys at least tore it halfway down, which is the idea. Now there's one more thing to do, so just hang in there because I want everyone to see it. Okay. The one more thing to do is kind of to open it back up again. I suppose hold it like a hot dog, or maybe a better way to say it is you want to droop the paper over your finger. I actually have my middle finger in here, but you droop the paper over it. Okay, and then with my thumb and my forefinger, I'm going to kind of grab the corners. Okay, so my thumb and forefinger are grabbing the corners. Remember, it's kind of like drooped right now. And I'm going to push in. I'm going to push in, and the book kind of becomes like three-dimensional as it kind of pops out, and I get. Okay, so again, I grab this. I kind of push in. It makes it actually go poof. This is actually called a poof book. Like who? Okay, so this is a poof book. But once you get it like three-dimensional like this, you just kind of fold it in on its binding, and you get yourself a 4-page book. And then fold it in gently. I'll let you do the folding in the middle there. Anybody else need help making it go poof? Okay, now, like I said, I'm going to give you a few minutes to actually make your book. Let me give you kind of the recommended table of contents here. Basically, you got the front cover. You can call it what you want, but I always think that's kind of cute. My first identity book. Again, you can call it what you want. If that's too cute for you, just call it identity book or something. But when you open it up, I'm going to suggest that you put the reciprocals and quotients, exactly like we wrote them yesterday, onto the first 2 pages, the reciprocal and quotient. In the middle of the book will be the Pythagoreans. And if you followed the way I showed it yesterday, there were 3 Pythagoreans shown by the 3 check marks. And then those arrows are trying to show you how to modify the equations. Okay, I can show you also if you're like, just want to ask if you're writing it down correctly. The last couple pages and the back cover will fill out together here in a few minutes. Okay, so again, you actually want to look at your notes from yesterday, and you're really just copying down the reciprocals and quotients and the Pythagoreans. Yeah, something good.
Like all 6 of them?
I would. Hey, there you go. I would put all 6 reciprocals, even though they're kind of almost in pairs. I would still put all 6. And then you've got 4 quotients. I guess really you have 2 quotients, and then you have kind of like 2 variations. And then you've got your 3 Pythagoreans. All right, now we're about ready to embark on quite a different chapter. I have said this kind of thing before, but I think it's important. Have a good attitude about it. Yes, there's going to be some things I said yesterday that are going to challenge you, and you might not always know the right answer right away. It might be that you have to work at it a little bit. It's all right to work at something. I'm definitely not trying to communicate that you're not going to be able to do the chapter. I just want you to be prepared that you might have to work a little more. And some of you are going to like this, and some of you are really going to like it. So you have to fit in one of those 2 categories. Okay? Either you're going to like it or you're really going to like it. Now, it's the algebra chapter. It's the algebra chapter. we're always trying to do legal algebra, okay? We're not going to be able to write down everything that's legal and illegal, but I just want to give you kind of a little bit of a taste because most of this chapter is trying to figure out what's legal or illegal. So what I'm trying to show you on the illegal side is some of the most common miscues. Now, a real common miscue is for students to take something that's true, like sine squared plus cosine squared equals 1. Okay, so that is true, but then do something to it that's not true. And this, again, is probably the most common mistake that students will want to somehow do this. Now, there's all kinds of problems with what's happened here. First of all, you can't individually take a square root like that. I'd have to take the square root of like everything. Even if I took the square root of everything, it's still not going to split up to be sine plus cosine equals 1. What I'm showing you here is that this is not true. Sine plus cosine does not equal 1 because you can't take the square root like that. Again, it's probably one of the most common miscues. Okay, so this is like a big no. I just want to make sure that you get the idea that no, sine plus cosine does not equal 1. Another real common miscue is for people to take sine squared plus cosine squared equals 1, which, by the way, is true, and then sort of say that, oh, well, I guess that means that sine squared minus cosine squared would have to equal -1, right? Right? No. Okay, sine squared minus cosine squared would not equal -1. Again, that is not true. Actually, if you do want to talk about something that equals -1, you just have to do it legally. So let's go over to the legal side. It's usually better to talk about what you can do. Now, again, we start with something true. Whoops. We start with something true. Sine squared plus cosine squared equals 1. But we just need to do something legal to it. Now, again, if you want to talk about -1, all you have to do is multiply both sides of the equation by -1. Okay, since this is algebra, we're allowed to do whatever we want to both sides as long as it's legal. And indeed, you can multiply by -1 all day long. When you do that, you actually end up with a whole bunch of negatives, right? You end up with negative sine squared, negative cosine squared, and -1. Okay, so that's a yes. That is definitely true. Now, if you're like, what are we going to do with this? Well, keep coming back. Okay, I promise we're going to do stuff with this, but just giving you a little idea of how to do some legal algebra. Let me show you one more legal move. We actually did it yesterday, but I like to sometimes get it on your little book today. Here's something that's true, right? It's called the quotient identity. So that's true. Tangent equals sine over cosine. If I want to talk about a squared version of this, well, all I have to do is legally square both sides. And yesterday, near the beginning of the lesson, we said that tangent squared is actually equal to sine squared over cosine squared. So that's why. Because we squared both sides. Okay, now, again, as long as you do something legal, you will always end up with a true statement. But for this chapter, we're going to be talking about how to do things that are legal. And one of the sort of number one skills that kids are still developing is this common denominator. Now, I have to say, I'm pretty impressed. Those of you that did the preview activity on the computer yesterday, now again, some of you didn't do it. I just would ask, why? Why didn't you do it? And if you forgot, you got to do something to be a little more responsible. If you purposely didn't do it, again, I would just ask nicely, why? Why did you purposely not do it? Was trying to give you a way to start understanding some algebra, but I was very impressed. Those of you that did it, a lot of right answers. In fact, even the common denominator was either correct or really close to being correct. So this is actually the problem from yesterday. Now, this is a little weird. We're trying to add these two fractions. How do you add them? Well, you need a common denominator. And right now, the denominator is made up of a cosine and then separately a sine. Well, the common denominator would just have to be both of them. Now, what that means is that this denominator needs a cosine. Okay, now I got to be careful. I can't just write cosine down there unless I also multiply the top by cosine. Because you have to try to remember from algebra and when you were working with fractions, maybe like in junior high, that you always need to multiply the top and bottom by the same thing. So this one needs a sign because I want it to be common. So I can put a sign down there as long as I also multiply the top by sign. When you make a common denominator, you often have to put something into the fraction. In this case, I'm putting into the fraction a sine over sine or a cosine over cosine. Now, that gives me, well, usually something new in the numerator. So it gives me a 3 sine over the common denominator. It gives me a 4 sine. 4 cosine. Sorry about that. It gives me a 4 cosine over the common denominator. Now, the step that I just showed, you might skip someday because all that's going to happen now is we're going to add the numerators. And the reason I say that you might skip that step some days is because when you add the numerators, all you're doing is just putting a plus sign between what you just wrote down up above. And you have one common denominator. One common denominator. Okay, don't do something like add the denominators. We're not adding the denominators, we're just keeping it common. Okay, and we get 3 sine plus 4 cosine all over sine cosine. Now we will do something with that someday. Right now we just kind of added some numbers together, but we'll do something with this fraction. And we'll keep talking about common denominators, okay? Because I know from past that that's usually something that students need a little more help with. Now keep your book handy, but what I want to do now is kind of officially start going through the topics of this unit. And someday we'll do a new topic, and some days we'll practice some old topics. There will be a little more practice built into this chapter, but let us begin. Let's start talking about some stuff that we can do with the identities. All right, now, the first thing we're going to do is what I like to call verifying identities. We're going to verify. Again, keep your little book that you made handy. You might look in it. I guess I should also share that I have a calculator handy. We're actually going to be doing something with a calculator. It doesn't have to be a graphing calculator. It can actually just be any good scientific calculator. Now, just kind of think about what I have up on the screen, because if you're trying to verify something, you're somehow trying to show that it's true. Okay, so somehow we're trying to show that a identity, a statement of equality is really true, is really equal. So take this statement. Now, you've written this down a couple times. You wrote it down in your book. It's actually the quotient identity. It's at least a version of it. So what does that really mean? What does it really mean to say that cosine equals sine times tangent? It requires that you understand that x, that's written up here beside each of these trig functions, x is an angle. Now, the interesting thing is that it could actually be any angle. Okay, but whenever you do the sine of a number, you've done it various times this year. Whenever you do the tangent of a number or the cosine of a number, it's always an angle that you're plugging in. So what this would mean is that the cosine of an angle, now the interesting thing here is it could be any angle. So we kind of need to pick an angle. And I'm just going to do the picking this time. I'm going to pick 15 degrees. So it would be like saying that the sine of 15 degrees should equal the cosine and tangent of 15 degrees. Now, the cosine of 15 degrees and the tangent of 15 degrees, I don't expect you to know what these numbers are. And they even, when they come out on your calculator, kind of just seem like a lot of weird random decimals. But the thing that's true here is that these numbers, when multiplied together, actually will work out. So let's back up a step here, because I want you to see I want you to be able to kind of show some work. I want you to have something that you can follow. Yeah, it's honestly, and it's kind of the one thing that's kind of weird for students, because it's like it's any angle, any angle. So I just kind of picked 15. Just kind of wanted to pick an angle that we could start with. Take a look at what happens. Okay, take a look at what happens. I am jotting down these decimals just to 2 decimal places to make it a little easier to follow. Okay, so if I jot them down to about 2 decimal places, I guess that one should have rounded to 0.97, shouldn't it? Okay, let's make it a little better. But what happens, quite simply, is that it's true. That 0.97 times 0.27 really is 0.26. Honestly, in a real simple, or I should say, using a real simple numerical method. Numerical just means using numbers. We're able to show that sine really does equal cosine times tangent. Okay, now it worked for 15 degrees. It's going to work for any degrees. We're not going to do this except for this problem. That is, we're not going to require you guys to plug in a whole bunch of numbers. I'm just going to do it for this problem so you realize that it works for 15 degrees. It works for any degrees. How about 75 degrees? Again, just trying to pick some different numbers. Now, it's interesting when you pick 75. Tell you what, let's not pick 75. Let's pick 85. It's interesting when you pick 85 degrees, you find out that it still works. Okay, what do I mean that it works? Well, numerically, and sometimes kids want to know, well, what should I show? What you're actually going to show are these individual numbers. So it's just a little calculator exercise. So I show 0.99 for sine. I'm going to show, I guess, 0.09. If I'm rounding this carefully, the cosine would round to 0.09, and then 1143. So I'm showing these individual numbers. Of course, the whole purpose of this is to show that they're equal. And so I take one extra step. I multiply 0.09 times 1143. And it didn't come out maybe quite as clean as we want to, because we did a little bit of rounding with that 0.09. I suppose if I would have left that 0.09 as a 0.8, what was the number again? Oh, did I type something in wrong?
No, I mean, we did 65. Figure out that's
You're right. I could have rounded that a little better up to 1, and then we end up with an answer that looks even closer. So, yeah, the whole problem here, well, it's not really a problem, but the whole thing here is that these numbers are being slightly rounded. And so that's why it came out. Maybe it didn't come out looking quite as good as we wanted to, but it's true. It's true that sine equals cosine times tangent. Okay, now it's true for any number, for any angle. Let me help you guys to know how to type in one or two more of these. Usually when the squares get involved, there needs to be a little bit of input from the teacher. Again, how do you actually type in these squares? Now, there it is again, sine squared plus cosine squared equals 1. Okay, of course, that's always true. What that means is that it's true for any angle. You have to understand that I'm picking some angles, but there's really nothing magical about the angles I'm picking. I'm going to just pick 70, so we're kind of all looking at the same thing. Of course, if I'm going to pick 70, that means I have to choose 70 for both of these. Okay, because well, it has to be the same angle that makes sine squared plus cosine squared equal 1. Look at how I typed or how I wrote it on the chalkboard. That's actually how you also type it in. In other words, you have to put the square on the outside of the parenthesis. Okay, now if I type sine of 70 and close the parenthesis and then put the square, it'll be okay. I don't want to square 70. I want to square the sine of 70. Same thing with cosine. I don't want to square 70. I want to square the cosine of 70. Make sure you're comfortable. Make sure you're comfortable typing it in. There's a little bit of rounding, okay? And I'm saying to you that that's okay. I'm not going to make you guys write this down to a whole bunch of decimal places, but usually if we choose 2 decimal places, we can get the idea that this is equal. And this one's perfect because 0.88 plus 0.12, 0.88 plus 0.12 is exactly 1. Okay, of course, all of them are supposed to be perfect. That's why they're an identity. See if you can, I'm just going to do one more here, but see if you can show that cotangent, where do I want to put this? Let's put it here. See if you can show that cotangent times sine is equal to cosine. Cotangent times sine is equal to cosine. And you pick the angle. You pick the angle. Now, part of this was to make you guys kind of ponder, boy, geez, how do you type in cotangent? If you're kind of pondering that, you're probably not alone, but how do you type cotangent into your calculator? Did anybody else pick 20? That would have been kind of weird. Anybody actually picked exactly 20? Ah, okay, it's not weird. It's, I don't know, somehow we're thinking the same. I just need a number to type in. If you typed in another number, it's fine. How do you type in cotangent? Okay, simply the reciprocal of tangent. Okay, now be careful. If you hit shift tangent, that's not correct. It's not shift tangent. If you hit second tangent, again, it's not the inverse. It's 1 over. 1 over. Okay, our numbers aren't the same unless you typed in 20, but are you making it work for you? Make sure that your 3 numbers are working. I got 275. I got 0.34. And of course, the whole idea here is that this is going to come out to be 0.94. Did it work for yours? Make sure you know how to type in cotangent. Again, it's 1 over tangent. This one worked out nicely. Okay, now this is a real simple look at what these identities are saying. And quite simply, they're saying that they're always true. As I said yesterday, no matter what. No matter what means no matter what angle. Okay, no matter what angle, they will always come out true. And you're just trying to show that with the numbers. All right, now there's a little homework helper. It's not just these questions. When you look at the homework helper, you'll see that it also goes back through some of the stuff we did yesterday. Just trying to get you guys ready to embark on this chapter. We'll show you something else tomorrow. Each day we'll keep adding to what we can do with these identities.